The next section in Chapter 8 deals with bond energy. In chemistry, bond energy is the measure of bond strength in a chemical bond. It's the heat required to break 1 mole of molecules into their individual atoms, and the unit is typically joules or kilojoules per mole. As a little review, if we were going to break bonds, energy has to be added to the system. We call that an endothermic reaction. And the term that we will calculate, and I'll show you that in a second, but that's the enthalpy change, will be positive. If we are forming bonds, then energy is released. That is an exothermic reaction, and the enthalpy change will be negative. This reaction should look, or no, excuse me, not reaction, this equation should look relatively familiar to you because we've calculated enthalpy changes before. Just a couple of notes. If atoms are going to bond together to form compounds, remember that they are doing it so that they can obtain a lower energy than they would possess as individual atoms. When atoms combine to form a compound, energy is always given off, and the compound is going to have a lower overall energy. In this equation, we're looking at delta H, which is the change in enthalpy, and we can get some information from that. We can determine if it's endothermic, where energy is absorbed, or exothermic. So let's try an example. Some more stuff up there. Predict the change in enthalpy for the following reaction, given the following information. So here we have some bond energies, and the question is calculate the overall delta H for this reaction. Pause it and try it. The way that you would calculate this is you would take the 3 carbon to hydrogen bonds and add that to the carbon to nitrogen bond and the carbon to nitrogen triple bond. You would subtract from that 3 more carbon to hydrogen bonds, a carbon to carbon bond, and a carbon to nitrogen triple bond, and you would get an overall change in enthalpy. And that will sum up section 8.